Good morning, good evening, good afternoon, and good whatever time it is for you. Thanks for joining today's community meeting. Today is Wednesday, January the 11th, and in the agenda for today, we have a review of the support for WireGuard in multi-cluster environments. If I'm not mistaken, I believe that I'm correct, and Jiajing is going to lead the discussion. Is that correct? Am I
yeah.
right? Perfect. So go ahead, Jiajing. Over to you.
Okay. Let me share my screen. Can you see my screen?
Yep.
Okay. Let's start. Today's topic is Antrea multi-cluster secure tunnel. We will implement this secure tunnel by the WireGuard tunnel in Antrea multi-cluster. So, I'm sorry. This is Antrea. The Apple keynote has corrected my spell. Hello everyone, welcome to join the Antrea community meeting. I'm Hu Jiajing from Antrea team. Today I will introduce the secure tunnel in the Antrea multi-cluster. Okay, let's start. Firstly, let's review the architecture of the Antrea multi-cluster. There are gateways in each cluster, such as the node C and the node B. There are gateways. All the gateways are responsible for the cross-class traffic. So if one pod in a cluster want to access to another pod, access to a service in another cluster, it will forward the packets to the gateway, and the gateway will communicate with other gateway by the Geneva tunnel, such as just like this. For example, if a pod in the pod A, it will access the service in class B. Firstly, it will forward the packet to the node C, the gateway, and the gateway will forward the packet to the remote gateway by Geneva tunnels, just like this. And when the traffic get to the class B, the gateway will forward the packet to corresponding pod. This is the current implementation of the multi-cluster, but it is based on the Geneva tunnels, just the generic network encapsulation technology. But it is a pity that this is not a secure tunnel, which means that it cannot guarantee the security of the traffic. Sometimes we are focusing on the security of the traffic. For example, in one company, there are some departments in different cities, and different cities for different services. If one team want to access to another team's service, maybe the traffic it will go through public network. So in this situation, we will focus on the security of the traffic. So in order to solve this, there are many secure tunnel. There are many open sources secure tunnel, such as WireGuard, OpenVPN, L2TP, and so on. And why we choose WireGuard? It is because that in some WireGuard is easy to use. We just need a endpoint and a public key. We can just add another node as peer. For example, we don't need maybe some other handshake or some other operations. We can just add a peer, add a node as a peer in local. So it is very simple and easy to use. What's more, it is in the Linux kernel, so we don't need to install extra softwares. Some other advantages. It is minimal attack. It has minimal attack service and high performance. In some benchmark test, the WireGuard may be the best secure tunnel in performance. So, as it has so many advantages, so we choose WireGuard to implement in our design. Yes, this is a design architecture. Not too much difference with the previous one. Just we replace the Geneva tunnel with WireGuard tunnel, but actually we do not replace. We just encap again, encap the Geneva packet into WireGuard, and then the gateways will communicate with each other by WireGuard tunnel. Which means WireGuard tunnel is responsible for all the cross cluster traffic, but in cluster, the architecture will not change. Why we choose this architecture is that we are trying to avoid too much unnecessary addition of the flows and the architectures. So we just encap the Geneva packet into WireGuard. That we want to do. So in this section, I will introduce the details of the design. I think maybe the WireGuard tunnel in Antrea multiple cluster can be divided into 4 steps. The first step is initialize the WireGuard interface on gateway node. Once we annotated a node as a multi-cluster gateway, we needed to create network interfaces of WireGuard, such as maybe WireGuard 0 or maybe Antrea MC WireGuard. The WireGuard interface is responsible for the WireGuard traffic. In addition, we cannot add the we cannot use the OVS attach command to add the WireGuard interface to OVS because it is a layer 7 interface. The first step is initialize the WireGuard interface. The next one, once we annotated node as a multiple cluster gateway, the multiple cluster controller will watch the gateway and export some cluster information to others, such as gateway information, server-siders, and others. It means that one gateway, one cluster info import. So we can consider that one gateway is one WireGuard peer. So the next step is add WireGuard peers. We implement this with the help of CRD cluster info import. After we added all the peers, maybe not all the peers, but add peers, we need to generate the corresponding OVS flows. Such in our current implementation, one server-siders, it will be maybe one or some, maybe not one, some flows to corresponding clusters. So one cluster will be, if one cluster was added as a peer, the controller will need to generate the corresponding OVS flows. After all, we have mentioned it before, WireGuard is a layer 3 interface. So if we want to use WireGuard to communicate with other clusters, we need the help of host network. So we need the last step is generated the static route on the gateway node. There are some steps such as clean and update, but this is not the key step, so I didn't mention them here. This two flow chart is the controller process. The first one is if we disable the WireGuard, or maybe if we disable the WireGuard, the controller process will be like this. Firstly, we need to init the multi cluster, such as maybe class set and class claim, and add the cluster to class set. After one cluster was added to a class set, we need to create gateway to enable cross-class traffic. Create gateway is we just annotated a node as a gateway. Once a gateway was created, the controller will do two things. The first one, the controller will export the local cluster info to other clusters, and then it will import other cluster infos and add flows to the remote gateway. If we enable the WireGuard, there are some more steps. After we create gateway, we also need to export the cluster info. But if since the WireGuard is enabled, we need to init WireGuard interfaces, such as network interfaces and others. And the WireGuard interface is up. We need to we will generate some public key. Public key, and export the public key to other clusters. So the local cluster can be added as peer by other clusters. The last step is host static route we just mentioned before. Just this is this step. Oh, sorry. And about the import cluster info. Once we imported a cluster info, it means that there is a cluster, there is a remote gateway. So if we enable WireGuard, we should add them as peers and add flow to remote. So there are maybe four extra steps to init WireGuard and add peers. So let's continue. This is a detailed design to init WireGuard. In the current process, we just use a dummy key in the rate limited queue. Once if something changes in gateway or in cluster info import, gateway and cluster info import are two CRDs. So for multi-cluster, if something changes, there is a key. The key is a dummy key, just we just need the key to trigger the process. So if something changes, we will include a key. And this one is process next work item. It is a Kubernetes functions for Kubernetes controller function. If it will try to get the key from the queue, and if the key is okay, sorry. If the key is okay, the controllers will list all the cluster info import and add flows for each cluster. I have mentioned before, one gateway, it means one cluster info import. So it means that and one cluster only has one gateway. So one cluster info import means one cluster. So we will list all the class info import and add flows for them. It means that we will add flows for maybe every member clusters. But in the new process, if we enable the wildcard, there are something new. The first change is the enqueue function. If something changes in gateway, we just enqueue a gateway key, and it means it is a dummy key too. We just need a gateway key to trigger the process. But if something changes in the class info import, we will not enqueue the dummy key, but the class info's name. Why we do this? It is because that we should add peers for each cluster, and sometimes if a remote cluster is restart, or maybe the Antrea multi cluster controller is crashed, the wildcard public key will be regenerated. So we should update the peers. But if we use a dummy key, we should list all the class info import every time, and check the peers and add peers and update peers. It is not maybe it will cost too much time. So we in this situation we will include the class info importer's name about the process next work items function. If a key is popped in the queue and the wildcard is enabled, we will initialize wildcard interface just mentioned before. This is the first step. I have mentioned before, just like this. But if this key is not a gateway key and the wildcard is enabled, it means that there is something changed in a cluster info importer. So we should do something, maybe just add peers, update peers, and add flows. So if the key is not gateway key, it means that there is a cluster info importer in the queue. So if the interface wildcard interfaces is not ready, it means that the wildcard interface is not initialized. Maybe we should enqueue again and wait for the interfaces. But if the key interface is ready, we should get the corresponding class info import and add wildcard peer and add flows. The last step is update host static route. So in this process, we will add wildcard peers with the help of class info import. So there must be some change in class info import. We should export our public key, our wildcard port, and other information in this CRD. We will mention this later. The next step is add and update peers, and this one is this step. I had just mentioned a class info importer. It means a remote gateway. So and a remote and a cluster only has one gateway. So a class info importer means a remote cluster. So if there is something changed and update in the class info importers, the controllers will try to update the peers. So let's continue. This one is about the flows and the static route. The wildcard is a layer 3 technology. So, and we should use if we want to use this technology with OVS, maybe we should we need the help of host network. So firstly, we will add we need to add rules for the host network. But in the current implementation, all the class traffic will be sent to the port Antrea tunnel 0. This port is responsible for all the cross class traffic. And it is the other side of this port is a Geneva tunnel. So our in our implementation, we should try to hijack not the correct word, but it is okay. We should hijack the traffic out of the Antrea tunnel 0 interfaces. So we use a packet mark in this flow. This is the previous flow, and this is the current flow. The difference is just this action. We will load a value to a packet mark register. If we enable WireGuard, we should mark the packet as the WireGuard packet. So we should add a mark. There's the only difference between the old flows and the new flows. After we add the mark, we should add a host IP role, just like this. If it will check the mark and look up the Antrea multiple cluster table. As for the Antrea multiple cluster table, the default device of this table is the Antrea multiple cluster WireGuard interface we just created before. So in this way we can do the minimal change of the flows. We just need to change one flows for the multiple cluster, and we will not change other flows. This flows we just need to add actions. So the output of the output of this flows the output of the traffic cross class traffic is Antrea 0 under the Antrea multiple cluster WireGuard interface will hijack the Antrea 0's traffic. So we can communicate it with other cluster by WireGuard tunnel. That's the implementation. So let's continue. This is the change of CRDs. Not too much change. Only the cluster info import CRD has been changed. We add a new field in this CRD. It named WireGuard, and by this CRD, we just need to export the public key and the port. WireGuard is easy to use, so we can just use this tool. We can just use this two argument. Actually, we need the gateway IP too, but the gateway IP and the self-siders has been exported before, so we just need to add a new field. Okay, let's come to the summary. The first summary is that the flows are almost the same as the current implementation. We just need to do we need to change is this flow in L3 forwarding table. And the second summary, the output port is Antrea tunnel 0. So we need an IP role on the host to hijack the traffic. The IP role and the static load. The third one, The gateways export the WireGuard public keys and port by CRD cluster info importer. Yes, we just need to add a new field in the CRD definition. The last one, the CRD cluster info importer is responsible for exporting the public key to other clusters. Once a new cluster info importers or maybe a cluster info importers has been updated, the controller will try to add a new peer or update the peer. This is the packet traffic. The left one is the current implementation. We will, if the packet from port A to port C will go through the VTL tripel and the Antrea tunnel 0, and it will be forwarded to the gateway. Once the packet reaches the gateway, it will go through OVS pipeline 2, and the OVS flows will get the destination gateway by the destination setter to choose which gateway is the remote gateway, and it will forward the packet to the remote gateway, and this is the third OVS pipeline. Finally, we reach the port C. In our implementation, there's not too much difference. Just with the only difference is that on the gateway node, we will add a WireGuard interfaces. Once a packet comes out from the Antrea tunnel 0, it will be encapped again by the WireGuard interfaces and be sent to remote gateway by WireGuard tunnel. That's the difference. Not too much. In this implementation, we just need to do the minimal changes of the flows, the architectures, and the CRDs. We need to do is create a new interfaces and modify one flow and add a new field in one CRD. Not too much changes of the architecture. So that's why we choose this implementation way. Finally,
I think we
please.
lost you for about 20 seconds. So yeah, while you are discussing the slide, we lost you for the past 20 seconds.
Oh, sorry, I do not hear clearly. 20 seconds.
You were not audible for the past 20 seconds, so maybe you can just repeat your last sentences. That would be great.
Yeah, I think I think for the last 30 seconds, I heard it clearly. Maybe thought it's your network issue. I don't know. But judging coughed a lot, so we may lost 2 or 3 seconds.
Okay. So maybe it was
yeah.
just my networking issue. In that case, it's not a problem. Sorry.
Should we repeat it again?
No, that's okay. Go ahead. Sorry. My
Okay.
apologies for the interruption.
No, it's okay. Sorry. So let's come to the demo. This demo will show the difference between the current implementation and the WireGuard. We will check the how the traffic come to the remote gateway and the remote clusters. There's a chat. Okay. Can you see my screen? I opened a terminal.
No,
Hello?
it's still the
No.
PPT.
Mhm.
Oh, sorry. I think this one will be okay.
Yeah.
Okay. Can I open a terminal now?
We can see
I
it.
have. Yeah. Okay. Thank you. I have created two Antrea cluster, Antrea multiple cluster before, so it will maybe save some time. The first one, the KE command, it means that east cluster, and the KW command it means west cluster.
Sorry, Jiajing, looks like your terminal is transparent, and I can also see the background. I'm not sure
Yeah.
it's the same as others, or maybe you can, yeah, it
Maybe
would be
I
better to
can-
see the information you input in the terminal.
Okay.
Or you may just close the, yeah,
Okay.
looks better.
Okay. Thank you. In this Antrea cluster, there's three clusters. There are three clusters, which named cluster east, cluster east, and cluster west. Okay. There's two member cluster, east and west, and there is a server in the cluster west. It's an Nginx server and a client in cluster east. And the cluster west exported service to cluster east. We can get the service now. This one is the service exported by the west cluster. Well, open another terminal to check the flow. Okay, let's try to call the remote service. Okay, we can see that if we disable the WireGuard, the traffic between clusters will go through the Geneva tunnel, just like I have TC, just like this. It will go through the Geneva tunnel, and actually the first step is to forward the packet to the gateway node, and the second step is the gateway node forward the packet to the remote gateway. That goes through the that disabling WireGuard situation. So there's another Antrea cluster enabled WireGuard. Let's see the difference. There's also a server and a client, and the server is also Nginx. And in the cluster east, there's a client. So let's check the service. Okay, the Antrea cluster west Nginx is the service exported by the west cluster. Let's try to assess it. The command KEW it means that cluster east with wildcard. Okay. It works well too. Let's let's check the traffic. Okay.
So judging when you say the KEW is the least cluster with WireGuard, actually you're moving to another demo clusters, right?
Yeah.
Okay. So maybe you can
Oh.
show us the alias of the command to let us understand what exactly do.
Oh, yeah, because it every command to use the use argument the group configure it is too long. Let's check the interfaces. We can see that there is a network interface named WireGuard Antrea MC WireGuard 0, and let okay, let's clear it again. We can see that the WireGuard the traffic will go through the WireGuard the WireGuard 0 interfaces. Let's get more information about this. Oh, okay. Oh, sorry. Let's trace the Geneva tunnel, the Geneva interfaces. We can see that the traffic goes through the Geneva interfaces too, and by the time and the TTL, we can find that it will go through the Geneva interfaces first, and then encapsulated by the WireGuard interface again. This one is the Geneva package. Okay, let's check the cluster info importers. Oh, okay. This one is on East cluster, and okay. Let's check the WireGuard client. We can see that there are some traffic transferred by the WireGuard. Sorry. As for the cluster info import CR, we can see that there is a new field named WireGuard in the spec, and it will export the public key and the port to other peers. Let's compare. In the previous, if we disable the WireGuard, we can check the WireGuard. We can check the cluster info importer. Okay, in this situation, there is no WireGuard. There's no WireGuard field in if we disable the WireGuard in multiple cluster. But in the if we enable this, it will export the port and the public key to other peers. Okay. Okay, let's see. Okay, that's all I want to share. The WireGuard over the Geneva, and the WireGuard is hijacked the Geneva tunnel and responsible for all cross-class traffic. In implementation, we just need modify one flows and one CRDs. Add a field to one CRDs. That's my shell. Thank you.
Hi, Jiajun, can you show the IP root configured on the cluster with WildCard enabled?
Okay. Sorry, I forgot to mention. We will add a new cluster rule and like this. Hi, Chan. Can you see my screen? That's what you want to see. Is that what you want to see?
Yes. And you have a route in table 10 to redirect the traffic to WildGuard's device. Is that correct?
Yes. The default device in table 10 is the WildGuard Antrea multi-cluster WildGuard 0.
Okay. Is this when we mark the packet with this specific MAC, do we filter the traffic must be cross port traffic, cross cluster traffic? Yeah. What's the condition of this mark? It will be on every packet, or it will be cross.
Okay, I know. Sorry. I will show you the flow first.
Sure, thanks. I joined the meeting late, so maybe this you already answered the question in the slides. I'm sorry for that.
No. I think this question should be answered and should be what we add this mark by the server side. So sorry. By the server side, I think. In this flow, and this flow will match the remote server side. It's just like this. If and the server side is the cross-class traffic server side. If I don't think maybe there is in class traffic will be marked, will be added, will be load this mark.
Okay, I see. Does this mark for D2 has any special meaning, or it's just an example?
Just an example, not many special meaning.
Okay, got it. Thank you.
Yeah, Chen, actually for this one, I'm also wondering for the packaging mark, do we have any rule for this one? Any number rule we should follow?
We already use the list 8 bits, and I think you could start with the nice one, and then maybe you use some constant to reserve, for example, how many bits you will use to avoid a future conflict.
Yeah, sure.
Thanks.
Hi, Jijing. I have a question on whether this is like internode we will be using WireGuard, or it is only like intercluster.
Sorry, I didn't hear clearly. Can you repeat your question again? Sorry.
Yeah,
sorry.
my question is for internode traffic, right? We are using IPsec, if I'm right, and for intercluster, you're planning to use WireGuard, right?
Yeah,
that's correct, right?
Yeah. In cluster, we sometimes we will not use the IPsec. Maybe we can just choose to do not use let let me think. In cluster, maybe we will not use we will not use any tunnel. We just use Geneva.
Yeah, I think for maybe I can answer this question. For in-cluster traffic, for now, I think currently we support only common tunnel like the Geneva, GRE, etc. And we actually don't support WireGuard tunnel when we have multi-cluster feature enabled, which means if we like to, we want to add WireGuard for the cross-class traffic, we will not support that. You can think that it won't work if both multi-cluster and in-cluster use WireGuard. For in-cluster traffic, WireGuard is also considered as a tunnel type, just like the Geneva. So if the user changes use the WireGuard for the in-cluster traffic, it means the cross-cluster traffic won't work.
Okay.
But for now, I think we haven't decided to support both in-cluster and cross-class traffic with all WireGuard. As you know, for the cross-class traffic, we actually encrypt the tunneled traffic, right? So the Geneva packages. And if this WireGuard, it means a WireGuard based on WireGuard. I don't think that will work. Yeah.
Okay. And what about like we are like choosing IPsec? We are not choosing IPsec. We are choosing WireGuard. Because IPsec, in some other conversation, like it is FIPS standard, like Federal Information Processing Standard, and WireGuard is not. So there, I think we might have some kind of regulatory compliances for some customer.
Yeah. Actually, this feature is comes from customer's requirement, and the customer is want to use WireGuard. So actually, this is why we use WireGuard.
Yeah, I mean, yeah, many customers are looking, but federal customers want like FIPS compliance, which is like IPsec. So,
yeah, I think we may start with WireGuard, but we may do have some plan in the future for the IPsec as well. And yeah, it's also in our to-do list.
Okay, I mean, there was one discussion where like they wanted to use Antrea because it was like IPsec, their image IPsec compliant image, and so they give like preference to Antrea for that. So yeah, especially federal customers. Yeah.
Yeah, okay, thanks. Good to know that. Maybe yeah, we can prioritize that, but it depends on the whole development plan. Yeah.
Yeah, sure. Thanks.
Hi, Judge. Question from me. So, do we need to disable the API filter on the WireGuard interface? If I remember correctly, during the previous test, we need to set the API filter to 0 in order to.
Yeah.
Yeah. Go ahead.
Actually, we don't. I got your question, and actually we don't need you to disable. I did nothing when we use the WireGuard across in multi-cluster, but it works well.
Okay, good to know that. So you mean that the original route that's strange. So how can that happen if the default route without the packet mark is not?
If we do not use the packet mark, it will go through the Geneva tunnel directly, and the WireGuard will get no traffic.
but we don't need to disable the IP filter.
But maybe it is set to 1 as default. I remembered, not 0 and not 2. I checked this argument and it is set to 1.
I think 1 means strict mode. So, yeah, for yeah, maybe we can check it offline. Yeah, thank you.
Okay, yeah.
All right. Are there any other questions?
Hi, Jiajing. If there are more than 2 clusters in the cluster set, do we have multiple flows, and do we need to use different marks for in the open flow laws, and to match different marks for different remote clusters in the IP rule table?
Yeah, I got a question. I think maybe we do not use the we do not need the different mark, because the mark is just is just to match the IP rule and to the table, to the Antrea cluster table. But for more than one member clusters, I didn't actually I didn't test this situation, but I think maybe maybe the WireGuard. I think it we don't need, because because the destination of WireGuard can because the destination of the remote the packet is the remote gateway, so the WireGuard will send to different different pairs for different gateway. I will check this. I will double check this situation offline, but I don't think I think this is more than one member cluster and more than one pairs. It will works okay.
Okay, thank you. So at least we need 2 flows in this layer-3 forwarding table to each of them match one remote cluster, right? Because the network destination condition is different for different cluster.
Yes.
And they could share. Yeah. Please go ahead. I just mean. I just want to say. I just wanted to say, if there should be one open flow rule for each remote cluster, do we consider we just have more IP rule in the host network to match the destination gateway IP, so we don't need this mark and we don't need the open flow rules? I'm not sure whether it could work, but if the purpose of the open flow rule is just to identify traffic to remote clusters, then I guess we could also use destination IP as well. Did we consider that?
Chen, I think Jiajing only added the mark load action. For other fields on this flow, it's actually required by common multi-class traffic. So it's if you mean that we can replace this flow for WireGuard, but it may works, but I don't think it will work when we have no WireGuard, if we remove this rule.
You mean this rule already exists? We just add one action. Oh, I see. I see. I see. Then it makes sense.
Yes, and I think maybe we use this way, and we should add we should we can add the package mark to the package, even the WebGuard is disabled, and so it will not there is no influence for the cross cluster traffic. So I think this is maybe more convenient. Yes.
Yeah, sure.
Hi, Sawato. I think there are no more questions here.
Good run, because also there is no more time. We are right at top of the hour. I thought we have a little bit more than 1 minute left, but since there are no more questions, I believe that we can conclude today's meeting unless the team wants to bring up any other topic for discussion. Waiting for a few more seconds. And I believe that this might be all for today. So thanks everyone for joining, and most importantly, thanks Jiajing for this great presentation and demo. That's been extremely informative. I have to be honest with you, I still have to digest everything that you presented here, but it looks great. So thanks a lot for this, and we'll meet again in 2 weeks' time. For the next community meeting, we will be back to the normal timing of Tuesday, 5 a.m. Greenwich GMT. And that's all for today. Thanks everyone for joining, and see you in 2 weeks' time.
Thank you. Bye.
Thanks.
Cheers.
Yes.
Bye-bye. Bye.